All right, we're back in live again. This is your pressure temperature lab, and it again is a lab where I'm not going to do any of the theory for you. You're going to determine the theory that you should be getting out of the lab yourself. So all I'm going to do in today's lab is quickly walk you through some instructions. So to do that, I'm going to go ahead and share right off the bat the instructions for you. So print off the instructions, pause me again if you need to. I promise I won't go on without you, just pause me. Did you pause me? Okay, hopefully you printed out your lab. Let's read through it together really quickly. This one's a lot more straightforward procedurally than the Boyle's Law lab, actually. So let me see if I can share that here. And again, it's weird. My camera needs to be lower so that I'm not looking. See, I'm looking up at, I don't know, it's weird. I can't make eye contact with this because I can't see myself. Ooh, now 3D. Ooh, filming in 3D. Way too interested in the camera. I apologize. I'd say like that, but you know at this point that's not the case. Share application, share files. Let's see. Aha! All right, so now you should be looking at the pressure-temperature relationship in gases Prelab with me here. Let's go through it real quickly. What you're going to be doing is, in this lab, you're going to be holding your number of moles of gas constant. Your number of moles of gas isn't going to change, and the volume occupied by that moles of gas aren't going to change. Those two variables are being held constant. Volume of gas and amount of gas, number of moles. Because what you're doing is you're going to take your flask here, and you're going to put air in it. And by put air into it, I mean you're going to take your flask and just stick a stopper in it. You're not putting in any particular gas, just regular old air, and you're putting a stopper in it, and you're not going to let any air in or out of your flask at all during this experiment. Obtain and wear goggles. Prepare a boiling water bath. Put about 800 milliliters of hot tap water in a 1 liter beaker and place it on a hot plate. Turn the hot plate onto its highest setting. Water boils at 100 degrees Celsius, but to get it to boil on a hot plate, you need to turn that puppy all the way up, well above 100 degrees Celsius. Because that 100 degrees Celsius, the hot plate tells you is just the surface temperature. So you're going to have to turn it all the way up. Also, notice how it says about 800 milliliters. Do not measure out 800 milliliters, right? That would be a waste of time. You're just wanting some water to stick the flask that you put the gas into, right? You're making a water bath right there. So when they say about, they mean about. You can use those pretend markings on the side of your beaker to measure. That's fine. Now prepare an ice water bath. Place about, again, about, don't get out a graduated cylinder, about 700 milliliters of cold tap water into a second 1 liter bath. Add ice. Again, the purpose is just to make a water bath here. Then you're going to make 2 other water baths, one at room temperature water, one at hot temperature water. Then you're going to prepare your system. You're going to connect a gas pressure sensor to channel 1 and a temperature probe to channel 2. You're going to obtain a rubber stopper assembly with a piece of heavy walled plastic tubing connected to the walls of one of its 2 valves. So you've got a double stopper here. One you're attaching to a flexible piece of glass tubing. The other you're connecting to a turned off and on valve. You're going to leave the 2A valve of the rubber stopper open at the moment, and still you get to step 6D. Close the, well, now you're doing it in step C. Close the 2A valve of above the rubber stopper. Do this by turning so it's perpendicular. So you're, at this point, you're shutting it off. You're keeping that amount constant. Open up the correct computer file, collect data. Notice at no point during this experiment will they ever tell you to open that valve again or remove the stopper once it's started. You're going to place the flask into the ice water bath. Make sure the entire ice water bath is covered and stirring. Place the temperature probe directly in the ice water bath. When the pressure and temperature readings have destabilized, and remember, you're probably not going to get stabilization in the last sig fig for your pressure, but you should be able to get that thousands, hundredths, and tenths fairly stable. Once you get that stabilized, click keep. You now have your first set of pressure temperature pair. Now you're going to repeat the process using the other 3 water baths. At no point are you to change your stopper. Don't open that stopper valve. Don't remove the stopper. Don't twist the stopper valve. Be careful not to burn yourself when working around a hot plate for the hot water bath. Then you're going to simply go through some graphing exercises just like you did in the Boyle's Law lab. Very easy, very straightforward, no annoying plus 0.8s for this lab like you had the Boyle Law lab. So it's really very straightforward, really very simple. I would be someone purely evil, nearly as evil as Kang. Everybody write down Kang. I know I'm mixing universes. I went DC universe last time. I'm going Marvel universe this time. Nearly as evil as Kang, if I went on any farther. So that's the end of this pre-lab lecture. Short, sweet, and to the point.